Using Pascal's triangle. Shown here is Pascal's triangle, which is very useful when looking at expanding polynomials. And in a later video we're looking at something called binomial expansion, which is based around Pascal's triangle. Now in Pascal's triangle you'll notice that this number 2 here is made by adding the two ones above it up to make 2. So if we pick this 35 here, it's made by adding that 15 and that 20 together, etc, etc. There's also several other patterns within this Pascal's triangle. It's kind of symmetrical down here a little bit. So we look at this row here, it goes 1, 6, 15, 20, 15, 6, 1. The edges are obviously all ones. The next row down is just 1, 2, 3, 4, 5, 6. And the next one down is the triangular numbers. But that's not what we're really bothered about. So Pascal's triangle. Use Pascal's triangle to help you to expand x plus 3 cubed. So remember, this actually means that we're going to be doing x plus 3, x plus y times x plus y times x plus y. And to do this would be quite a long-winded process, because the first thing we'd have to do is we'd have to expand the first two brackets, which would give us x squared plus 2xy plus y squared, and then we'd have to multiply those three terms by the x plus y, which is quite a long-winded process, but let's have a go at it just for this example. So x squared plus xy plus xy plus y squared, and we've still got to multiply that by x plus y. Obviously we can collect together the x plus y's in here to make 2xy plus y squared, and that is going to be multiplied by x plus y. Now if we expand that, we're going to get x cubed, so multiplying everyone by x first, plus 2x squared y plus xy squared. Now if we go through and do everything multiplied by the y, so we're going to have x squared y plus 2xy squared plus y cubed. And if we collect together like terms in this line here, we're going to have x cubed plus, so x squared y, we've got 3 of them, xy squared, we've got 3 of them, and we've just got the y cubed. Now if you look at the coefficients, now the coefficients is the number in front of each of these terms. We've got 1, we've got a 3, we've got a 3, and we've got a 1. And if we go back up to our Pascal's triangle, you'll notice that on our fourth row, because remember we've got 4 terms in our answer, we've got 1, 3, 3, 1. And that's not inconvenient. And that is how Pascal's triangle could help us with the expansion. Because if we're looking at doing x plus y cubed, we're going to be looking at the fourth line down. If we look at another example, and this time I'm trying to use Pascal's triangle to help, we're looking for 3x minus 4 all to the power of 4. So this means we're going to be looking at the 5th row down. So if we look at the 5th row down, you'll notice the 5th row down, so 1, 2, 3, 4, 5, we've got 1, 4, 6, 4, 1. And we're going to use that. So we're going to use the values 1, 4, 6, 4, and 1. And if we use them, we're going to have the 3x to the power of 4 multiplied by 1 plus 4 times 3x to the power of 3 this time, because you've gone down a power like in the one above, but this time the other one starts to appear, so we're going to have the minus 4. Next one we're going to have plus 6 lots, of 3x squared and minus 4 squared. So you've taken 1 off the power of the original part, the first part, every time. Oops, so let me change this one here. So this one here, that 2 shouldn't be there. Should of course be on the outside of the bracket. But the other one is going up. So minus 4, now it's minus 4 squared. Next one will be 4. From our Pascal's triangle, we're going to have 3x. And this time we're going to have minus 4 to the power of 3. And finally, we've now got 3x to the power of 0, which is just 1. So we're going to have 1 times by minus 4 to the power of 4. And this is actually pretty much the binomial expansion which is given to you in your formula book in the exam, and we'll look at on a later video. Because obviously we don't want to be drawing out Pascal's triangle every time. And that's where binomial expansion comes in, which we'll cover on a later video. Now if you sort out each of these terms, so do minus 3 to the power of 4, you get 81 times by 1. So that first bit becomes 81x to the power of 4. The second one would be minus 4 times 3 to the power of 3 times 4, which is 432 x cubed. The same for the next one, so minus 4 squared, which is going to be 16 times 3 squared, which is 9 times 6, is 864 x squared. Next one will be a minus again, which is 768x. And finally, you've got plus 256. And that is how Pascal's triangle could help speed up expanding polynomials like this, because if we had to do this times by 3x minus 4 times by itself 4 times, it would be taking an awfully long time to do.